So in my earlier two videos, I did a quick start guide on how to set up the Elk stack with Docker Compose. And it was basically based off of these two, this documentation and this documentation provided by the Elastic team. And in this video, I'll just go into more detail of what I was actually doing and elaborating on what a lot of these guides were talking about, as well as filling in with extra information or extra insight that I may have gained over that time. Now, if you don't really care about the in-depth explanation, just simply click to the Git repository offered by this documentation, and just check out this project and do Docker Compose up, and everything should be just up and running right away. And there's hardly any configuration that's needed. I also did a Git fork of this project, and I'll paste a link to my fork of the project just in case. I did the fork just so we never lose access to this particular project, because some people or sometimes an organization may remove this project altogether. And if that happens, you can just go to my fork of the project to download the code. I'll leave a link to that repository in the description of this video. So let's get started. I'll explain in more detail everything that we did in the earlier two videos. And I will start by maybe showing this diagram I made. So when setting up the Elastic Logstash Kibana, or when setting up the Elk stack, this is what we're going to try to achieve. Ultimately, we want Elasticsearch, Kibana, Metricbeat, Filebeat, Logstash, Elastic Agent with Fleet Server and APM enabled. And let's have a web app that talks with the Elastic Agent, Fleet Server, and APM. Of course, if you don't want all these components down here, or any of these, well, the only component you really need is just Elasticsearch, and you could be running. It makes sense to add Kibana on top of Elasticsearch. But any of these other components, they're optional. You just enable the ones or install the ones that you want. But in our earlier two videos, we installed every single one of them. And of course, it's always easier to take things away than to add them on. So in this video, I'll just explain how all these things are added on. And I'll construct it one bit at a time. So the first thing that we're going to need is, or let me take a step back. Because we're using Docker Compose to set up all these things here, we basically need one Docker container to implement each one of these blue squares that you're seeing. So we'll need an initial Docker container to set up the certificates that we're going to need. Certificates as in the SSL certificates or the TLS certificates that many of these containers will need to communicate securely with Elasticsearch. And in terms of the actual certificates we'll need in this particular project, we'll need one for Elasticsearch, one for Kibana, and one for the for the Fleet Server. So in total, 3 sets of certificates, or one certificate authority that will sign 3 different certificates. A certificate authority that will sign the Elasticsearch certificate, assign the a certificate, and the certificate authority will also sign the Kibana certificates, and it will sign the Fleet Server certificates. All right. So this first container that we're going to spin up, the first Docker container that we're going to spin up, is only focused on creating certificates. Once those certificates are made, then we can move on to creating the second container, which is the actual Elasticsearch instance. We can't actually spin up Elasticsearch until those certificates are in place. So this container here completely depends on this container up here. So once this container has made the certificates, then we go ahead and make the Elasticsearch container. Once we've made the Elasticsearch container with the certificates and it's up and running, so we have a running instance of Elasticsearch, then we can move on to making the Kibana container. Right? So a running instance of Kibana. So we can't spin up Kibana until Elasticsearch is up and running. So Elasticsearch depends on this, Kibana depends on this. So that's already 3 Docker containers. Once we've got all 3 of these up, then we can choose to implement any one of these other Docker containers in any particular order. We could create Metricbeat first, or we can create Filebeat next, or we can create Logstash next, or we can set up the web app next, or we can set up the Fleet Server APM Elastic Agent up next. What this means that depending on what you need, you can just create the container or the running instance of that particular service if you need it. If you don't need any of these, then you don't need any of them. You don't need to. You can basically stop over here after you've done Kibana. So just to be a little bit thorough and complete everything, we'll just go in the order of Metricbeat, then we'll set up Filebeat, then we'll set up Logstash, then we'll set up the Fleet Server with APM, and then we'll finally set up a web app that communicates with the Fleet Server APM service. So that's what we'll do. And the other thing I'll say is that when setting all this stuff up, I'm going to focus my explanation mostly on things related to the Docker Compose file and just hooking things up so that they all work. In terms of explaining actually how Filebeat works or how Metricbeat works, or the inner workings of Logstash, Fleet Server, or the inner workings of Elasticsearch or Kibana, I'm going to gloss over details related to that subject because I already have videos that I prepared earlier that talks more in depth about each one of these services outside the realm of using Docker. And because we're focused mostly on talking about how to set up the entire Elk stack with Docker Compose, I'll focus my explanation mostly on the Docker Compose setup and how we're wiring or hooking all these things up. But as I go, I'll try to reference my earlier videos. And in the description of this video, I will leave links to key times in earlier videos that can speak in more detail of any specifics that you should be aware of. So in terms of what we're gonna work off of, I'm working off of Red Hat Enterprise Linux 9.2, and this is actually just a virtual machine running off of another computer in another office room here in the local network. So to access it, this is the IP address of this particular machine. So I'm going to reference it later on. And when I use Kibana or if any of my containers need to talk with Elasticsearch, I might need this IP address for later. Let's see what else. I think that's pretty much it. We might as well get started. And I'm just going to work from this project. And when I say work from this project, what I mean is if you want to and just want to get things up and running, just check out this code and just do Docker Compose up and you'll be up and running and everything. Everything should pretty much just work without too much more configuration. You'll have your Metricbeat, Filebeat, Logstash, the APM server. Well, the APM server requires a few steps to configure, which you'll see in my earlier video, part 2 video, I believe. So yeah, if you just want to be up and running in less than a couple of minutes, just check out this project and Docker Compose up. But what I'm going to do in this video is I'm just going to take piece by piece from this project and build everything up. Right? So that way you can see what is the responsibility of each segment of code. And the thing that I'm going to work from a lot is going to be this file here, this Docker Compose file. All right, so let's just get started. So I'm going to make a new folder. Here, let's just make a new folder here. So I'm going to make a new folder. And we're going to start with the Docker Compose file. Docker compose.yaml. And I'm going to start just pasting in things that I need, and I'll explain what each segment of code does. So first we're going to need to state our Docker Compose version. That goes without saying. You just need this line every time you run Docker Compose. So the next thing we're going to need are volumes. And in terms of what volumes are, so if I come back to this slide, when we set up these 8 different Docker containers, they need a way to share resources or share files between each other. And the files I'm thinking about specifically are the first one would be the SSL certificates and certificate authorities. So this first container is going to set up some SSL certificates. When this container makes those SSL certificates, those certificates need to be accessible by these 7 other containers. If this weren't a containerized environment, what I might do is that this might be one computer. And once we create those SSL certificates, I'll just use SSH or an FTP file uploader or just some other file transfer program to copy the certificates from this computer into this computer and then copy it to this computer, etc., etc., etc. But because we're working in a containerized environment, it's not necessary to use a file sharing program like SFTP or use SCP to copy those files from one container to another. Instead, we're going to do something called volumes, which is telling Docker to create some special places on our Red Hat Linux server such that later on we can copy files from here onto the Linux machine. So onto this Linux machine in a location where all these other containers can also access it. This way also, if you shut down your Docker project or you turn off your computer or you restart Docker and such, those files can persist with each new instance of Docker Compose up. Right? So those files will last. They're not volatile. They'll remain on your computer the next time you start up Docker again. So that's what these volumes are going to be for. They're just a way to tell our Linux machine that we're going to need to write some files from our Docker containers onto our host machine, our Red Hat Linux machine, and then have it accessible by other containers. Now you can see that there are, let's see, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7. There are 7 volumes here to reflect 7 other containers, or 7 of the containers that we're going to work with. Now I'm not going to set up all these volumes all at once. I'll just set up one volume at a time, just so you see which container relies on which volume. So let's start with, in fact, let's take a look over here. The first container we're going to make, or let me actually take a step back. You're going to see in this Docker Compose file that there's this one container here, the setup container, which is this one here. There is the Elasticsearch container, which is this container here. There's the Kibana container, which is this container here. There is the Metricbeat container, so that's this container over here. Filebeat container, so that's this one. Logstash container, that's this one. There is the Fleet server container. So this whole part here. That Fleet server container actually contains 3 services. The Elastic Agent, which actually sets up the Fleet server, and along with one of the APM integrations. So that's what this one container will do. Okay. And then there's the web app, which is this container over here. All right. So coming all the way back up, the first container we need to set up is a typical setup container to set up all our SSL certificates. And we're going to see right here when setting up this particular container that it needs access to the certs volume. So we're going to need this one first. So let me copy this and paste it in there. So that's the only volume we need at this point. If we want to, there is no harm in setting up all these containers right now, but I'm just going to focus on setting up this one first because I'm going to set up this container. And that way, hopefully you don't get confused in terms of which volume belongs to which container. All right. The other thing we're going to need is a network to, let's say, to allow communication to allow communication between all these different containers, at least for each of these containers to be aware of the existence of each other. Okay, so this I'm just going to copy and I'm going to paste into here. Okay, so I think just like that, we can actually start setting up our containers. So let's focus on the first container, which is the container responsible for setting up our SSL certificates. Let me just copy this first and paste it into our Docker Compose file before I explain it. All right, so this is the first container that we're going to need, which reflects this container up here. All right, so let's explain a bit what this container does. So the first thing that this Docker container will do is download a Docker image from the Elasticsearch repository. And the image we're going to download is the Elasticsearch image. And the Elasticsearch image basically will have all the code and software and tools that actually runs Elasticsearch. So I'm going to you know what I'm going to do is I'm going to open up an actual production server. So this terminal here is actually a completely different server. It actually has a running instance of Elasticsearch on it. And if I go to the etc Elasticsearch directory, these are all the configuration files that comes with Elasticsearch, and it's going to be included in this Docker image here. Right? And there's also these utilities here. In fact, I don't even have to go to binary. So this directory here, and if we go into, let's say, the binary directory here, we have all these executables that help us configure and use Elasticsearch. So this Elasticsearch Docker image will include all these tools and a running instance of Elasticsearch. So that's what this command will do. You'll notice that there is an environment variable here, and I already just realized I forgot to create an environment file first. So we'll come back to that in a moment. Right? So that's what this line will do, is it will download an instance of Elasticsearch for us to have the tools and commands and everything we need to actually create the SSL certificates. This next line here reflects the volumes that I was talking about earlier. So when we create those SSL certificates, we're going to need to share it with our other containers. So inside the container, we're going to create the certificates inside the Docker's directory for USR share Elasticsearch config search directory. But this directory is actually going to map to our local Red Hat host machine computer in a directory that's specified by this certs reference. Okay, so it's going to be in a local drive somewhere. Now, you're not supposed to know exactly where it is because this is what we call a volume mount. So the exact location of where the files are written to in your Red Hat or in your local Linux machine, it's supposed to be abstracted. You're not supposed to know. But if you really do want to know, it's going to be somewhere in maybe lib. Could be, and this could be different for every single computer, right? So if we go into, I believe, is there a volume? Here it is, volumes. So that certs directory, or let me come back to over here, maybe. So this certs references this volume, and because we're using a local driver, it's gonna be written to somewhere in this volumes directory, var lib docker volumes directory, somewhere in here. Okay, you're not supposed to access this directly, right? It's supposed to be abstracted from you, but I'm just trying to convince you that this volume just writes locally to your instance of your local Linux, your host machine Linux machine. Okay, so let's go back to our ES project. Right. So this bash script that we're about to run, it will create some certificates, write it to the Docker containers USR share Elasticsearch config certs directory, which maps to our local machines volumes directory somewhere. Okay, so that's what that part does. We're going to use the root user, so for user 0, and then we're going to run this big bash script. So in terms of what this bash script will do, the first thing it's going to do is check if you've set the environment variable for elastic password, which we're supposed to define in the .env file, which I'll do that in a moment. So it's saying if you haven't set your password, if you haven't set your elastic password, then we're going to exit this script. If you have not set the Kibana password in your environment file, we're also going to exit this script. The next thing is, if you haven't made your certificate authority yet, then let's actually go ahead and create it. In terms of what the certificate authority is, it's going to be the file that signed your actual individual certificates. If you don't understand what all this means, I'll link to earlier videos that explain more about Elasticsearch's self-signed certificates, certificate authorities, and how they're configured for your Elasticsearch, Kibana, and generally for your Elk stack. But just for now, all you need to know is that before you can make certificates, you need to make a certificate authority. And that certificate authority is actually going to be used to create the actual client certificates that each one of your containers need. Well, not each one of your containers, just your Kibana container and your Fleet server and your Elasticsearch container. So you need 3 of those 3 certificates. Okay, so we're going to make the CA file first, and we're going to make it with this command over here, right? Bin Elasticsearch cert util. And if you come back to this terminal window, so again, this is my production Elasticsearch server, and in that USR Elasticsearch binary directory, we have this command over here, right? And because the mention of this command is basically referencing this command. Okay, so in our Elasticsearch Docker container, we have access to this certificate utility to create our certificate authority. So that's what these 4 or 5 lines do. All right, so once we have the certificate authority, next we check if we have certificates made. And if we don't have actual certificates made for our Elasticsearch, for our Kibana, or for our Fleet server, let's go ahead and actually make it with this cert util command again. Right? So to make it, this cert util command, one of the things it can accept as an argument is a YAML file. And your YAML file can declare every instance or every certificate you need. Or let me take a step back. This YAML file can instruct the cert util command to know which certificates it needs to make. If you recall from our earlier videos, I would just run this Elasticsearch util command 3 different times, once for the Elasticsearch container, once for the Kibana, and once for the Fleet server container. Maybe that's too verbose of a way to do it. So by putting all the servers that you intend to create certificates for in one YAML file, then it's just a little bit less typing. Okay, so that's what this if block will do. Now, if you don't plan on using a Fleet server, or if you don't plan on using Kibana, you can omit these lines from your YAML file or from this bash script. But because we're actually going to have a Kibana and Fleet server, we'll include it here. Okay, so that's what this Elasticsearch cert util command will do, and that's what this if block statement does. If your certificate files already do exist, you'll just skip this if statement. Right? So once those certificates are made, it's just changing some permissions, and then we're going to wait for Elasticsearch to be available. Okay, so before I come back to this line here, I want to mention that you'll notice that the certificates are being written to this config certs directory, which is really referencing this directory here, which then references this volume mounted instance that we have up here. So then those files will persist every time we restart Docker. Or if we shut down the container or restart a container, our certificates will be available on the next run. So by the time we reach this line here, basically all our certificates are set up and we're ready to actually just load up Elasticsearch and run Kibana or start configuring Kibana. So really these lines here, so from these lines onwards up to here, they're kind of unnecessary if you don't care about running Elasticsearch or care about starting up Kibana. You can omit these lines, but really our next step would be to configure Elasticsearch and Kibana, in which case things are going to hang here on line 62, right? So the container will just kind of be stuck in this loop. So we have this until loop. It's going to keep trying to ping the Elasticsearch server every 30 seconds until it successfully connects with Elasticsearch. So if we don't set up our Elasticsearch container, our code execution or this bash script will just be stuck on this line indefinitely, okay? Which is a good thing because we don't want to configure Kibana because these lines here will set the Kibana password. And we don't want to do that if we can't even get Elasticsearch up and running, okay? So things are just going to wait here until Elasticsearch and Kibana are up. So before we move on, then let's actually create our environment file so that we do have the stack version, so that we do have the Elastic password and the Kibana password. And I'm going to come back over here. Let's just click back for a moment. And we will just use this environment file. So this environment file has, we need this variable, and this. And just for simplicity's sake, or just to speed things along, I'll just copy this whole environment file as is and just paste it all in here. All right. So again, the only thing we need for now would just be this Elasticsearch password, the Kibana password, and the stack version. All these other ones we're going to reference later on. So let's see if we're missing anything. Okay, we've got those variables and we should be able to run this container now. Oh, you know what? I should explain the health check. So this container is going to be marked as healthy. So this container will be considered healthy as long as this health check determines that the files, the ES01 certificate exists. If this exists, then this container is healthy. And if this container is healthy, then we're allowed to spin up the Elasticsearch container in our next step. Okay, so let's just test this out. And what I expect is that I want this container to run up until this line over here. Okay, so let's try this out. Docker compose up, and I'm just going to explicitly tell Docker I want to build things. And I just want -d to let this Docker compose run in the background so that I'm still free to type on my keyboard. Okay. All right, so that looks like it went fine. So let's say Docker PS, let's take a look at all our containers. And okay, this might be hard to see. So I'm gonna find another command that's a little bit easier. Let me just, I did this in my other videos, which is this command here. Let me just clear. So this is still also the Docker PS command, but I'm just shortening to see, I only want to see the ID, names, and status column and running for column. There we go. That's a bit easier to see. Let's do a Docker logs on this. And you can see that the container is still up and running. Whoops. And you can see that it is waiting on that line that I was talking about, which is it's stuck on this line here, or it's this loop is just running indefinitely until Elasticsearch is up. So that's good. Everything is working the way we expect, and we have our certificate files. You know, if you really want to know where it is or take confirm, you can always go into here, volumes, and let's yes, cluster certs. And you can see that our certificates are actually made here. Again, you should never have to work directly out of these directories. You should work through the Docker's container directories. Okay, so let's go back to our ES project, and we're ready to set up our Elasticsearch container. But I'm just going to take a quick break and I'll come back because I'm going to have to record this in over the course of several days or several parts. So let me just pause for a moment and I'll be back in a moment. All right, I'm back now. So let's go ahead and continue with setting up the Elasticsearch container. So if I open up my Docker Compose file, let's see, where were we? Right, this is the setup container, and we're going to set up the Elasticsearch container next. If we don't have the Elasticsearch container, then our setup container just stops at this line here until the Elasticsearch instance is actually up. So let's come back to this project, go to our Docker Compose file, and let's just grab the code for the Elasticsearch container, which is this one, and paste it in here. Now let's just make sure the spacing is correct. There's 2 spaces here. Yeah, because if there aren't enough spaces, sometimes we get syntax errors when trying to start things up. Now let's try to figure out what this container is doing. So the first thing we're going to do is say that we only run this Elasticsearch container, ES01, only if the setup container is in a healthy state. So this code here is from the setup container, and only when the Elasticsearch certificate, only when that exists, do we run this container. All right, so that's what this is doing. We're going to download the same Elasticsearch Docker image that we used in the setup container up here. And here we're going to use some Docker labels. From what I can tell, this just helps Docker find the appropriate Elastic log files to output to. And I think it's also used by Filebeat a little bit later. Now, I'm not entirely sure, but I also know it's not super important. It just helps with Docker logs and maybe for Filebeat to read some of the logs within this Elasticsearch container afterwards. So that's what these 2 lines are. Next is we're going to need to volume mount a few directories. So in order for our Elasticsearch instance to use the certificates that was made in the previous container, we need to reference the same volume. All right, so that's what this one does. And we've already declared the certs volume at the top of this Docker Compose file. We're also going to need to mount another volume, which is we're going to mount the Elasticsearch data directory to another volume that we're about to create. This way, the database that Elasticsearch sets up is going to persist. And every time we restart Docker, we won't actually lose the data that Elasticsearch has made. Because Elasticsearch will have written all the data to our host machine, to our Red Hat machine. So let's actually set up this volume at the top over here. And we can do ES01 driver. Okay, and it's also going to be on our local machine, on our host machine. So if we scroll all the way up here, you can see that they've defined it. Oh, ES data 01. So let me ES data and just make sure that ES data 01 is yes. We just need to make sure that this word is spelled exactly the same. So that's what those are the 2 volumes we're going to need for this container. Elasticsearch inside the container is going to run off of port 9200, but that's going to map to our host machines. Let's see, which one is it? Also port 9200, which we can change for security reasons a little bit, which we should change for security reasons, but I'm not going to do that here just because this is a demo, but you're free to change it later on. Okay, so next is we're going to configure Elasticsearch. Now, if you watch our previous videos, you'll know that we spend a lot of time configuring the elasticsearch.yaml file. So if I go back to my production machine, Elasticsearch, and we have an elasticsearch.yaml file here. I'm not going to open it up because this is a production machine, so I don't want to disclose all the secrets, but you're going to see that in this YAML file, there are a lot of configurable options. And instead of configuring it directly in a YAML file, we can just use these Docker environment variables, and it will load up these properties pretty much at initiation or at runtime. Right? So all these options are also available in this Elasticsearch YAML file, which I've talked about in earlier videos. So you can watch those earlier videos if you want more explanation on each one of these configurations. I would say that the most important parts are this Elastic password. It's going to be the one that you log in. No, not the one that you log in with. It's going to be the initial one that authorizes a lot of your API access to Elasticsearch. And that's in your environment file. We've got our cluster name that also came from the environment file. One thing I want to remind everyone again is that there are two ways for Elasticsearch to communicate with other services. This is for these few lines here are for the RESTful API, and these certificates, right now, they're going to use these self-signed certificates that we created in our setup container. And that is Elasticsearch's recommended way of doing things. But you can certainly replace these with publicly signed certificates. So certificates from Let's Encrypt or Sectago or any of these other commercial providers. So you can swap these out with with other publicly signed certificates if you'd like to here. Now these lines here is the transport protocol. If you have an Elasticsearch cluster with multiple Elasticsearch nodes, they will communicate with each other on a specific port, and all that traffic will be encrypted by these SSL certificates here, which we declared in our setup container. It is highly recommended that you use the self-signed certificates because the Elasticsearch nodes basically use the CA file, so that's this file. The Elasticsearch nodes basically use these CA files as an access token. If you use publicly signed certificates, which uses a publicly available certificate authority, then basically means that anyone in the public can access your Elasticsearch cluster. So it's highly recommended that you stick with the self-signed certificates for the transport protocol as well. So aside from that, I think these other things are just more memory things to help start up the container and prevent it from locking up. And for the health check, to let all the other containers know that Elasticsearch is up and running fine, we're just going to ping ourselves and make sure that it's available. And that's basically Elasticsearch container. So we can restart Docker, our Docker project. And I think what we're going to see is we're going to get past this line, and we're going to start seeing this line next, which is waiting for Kibana. All right, so let's try this out. I'm going to go Docker compose down, and I'll just remove any unnecessary, any hanging containers. And then let's just do Docker compose up, and I'll just build it again. I'm just used to typing build, and let's just see what happens. Okay, so let's take a look at all our containers. I'm just going to take our Docker ps command like this. All right, so it looks like both of these are up, and let's do Docker logs on the Elasticsearch ES cluster ES01. Okay, we're seeing some logs coming out. I don't really see errors immediately visible, so that's a good sign. And let's take a look at the Docker logs for the ES cluster setup. Oh, actually, one of our, okay, so our setup container has exited. Let me just see why. Oh, all right. So I was wrong, or I forgot something. So it looks like our setup container also actually ran successfully. It detected Elasticsearch. So then it went ahead with this step here. I thought it would hang, but it didn't hang. It didn't freeze because all this line does is set up the password for Kibana so that when we're ready to load up Kibana, we have a password to log in with. So it looks like everything worked out fine, which means we've got a running instance of Elasticsearch, and because Elasticsearch is up and running, this container just dies. The setup container is done, so it'll just exit itself, and we're ready to set up Kibana. So let's come back over here and move on to our Kibana container. So I'm just going to take this bit of code here, copy, open up our Docker Compose file again. I shouldn't have turned off, but whatever. Let's keep going. All right, paste in our Kibana container code, and let's examine what this does. So this one says it depends on the Elasticsearch instance to be up and running. So as long as in our previous container, we see that Elasticsearch is able to ping itself, then it's healthy. And if it's healthy, then we can move on to downloading the Kibana image, the Kibana Docker image from the Elasticsearch repository. And again, just some Docker labels to help with logging. And next, we're going to need to create some volumes. So we're going to map the Kibana certificates directory to our volume certs, which we've already defined earlier, just like we did for the setup and Elasticsearch container. We're also going to need to retain some Kibana data. So if we're setting up visualizations or setting up views, or just if there's information that Kibana needs to store so that it can be reused for subsequent runs of Docker, we're going to need to write that information to our host machine. And that's going to map to this volume here, the Kibana data volume. So we're going to actually define the Kibana data volume. Let's just copy, paste, and type this as Kibana data. And if we come over here, we can see that it's already defined up here as well. All right. So now that we've got that defined, we should be ready to look on the next one. All right. So we're going to bind mount read only the kibana.yaml file from the container to our Linux host machine on a kibana.yaml file. So this is a bind mount, which means that we're going to have to manually create this kibana.yaml file on our host machine. So we're going to create a file here, kibana.yaml. And in terms of what the content will be, it's available in this project. Let's just grab this. And let's just copy everything. And I'll paste it in. Wait, let me just make sure. It's kibana.yaml. Yes, it is. Okay. Let's paste that in here. And now these configurations I explained in several of my Elastic Elk installation videos. So I won't go into detail here. I think they're all going to be pretty explanatory. You can just watch my earlier videos for more deep dive explanation of these configurations. Okay. So we're bind mounting it to our Linux machine. So that way, every time we rerun Docker, we're not going to lose these configurations. So that's what this line is for. We're going to run Kibana on, or Kibana inside container runs on port 5601. Our environment file, which is exposed to, is saying expose Kibana publicly also on 5601. Okay, so you can change this to a non-standard, non-default Kibana port for security reasons a little bit later on. Okay, so that's the port. And as for these environment variables here, these are actually just additional options that you could potentially put in your kibana.yaml file. But in this project, in this Docker project, we're not going to put it in the kibana.yaml file. We're going to load these properties right at runtime or right at startup time. Okay, and they're pretty straightforward. Just all the things that I've explained in earlier videos. You're passing in your Kibana password for logging in. You're passing in your certificates. There are some encryption keys that can help set up or enable additional features within Kibana. Let's see, yeah, more SSL certificates or the certificate specific to your Kibana or the IP address or the URL that you'll be using to access Kibana. And let's see, this APM token, if you're not using APM, if you're not going to be using the fleet server here, you can potentially omit this line over here. But we are going to be using it, so I'll leave it in there. Some memory limit values to help with just starting up Kibana so it doesn't freeze or lock up. And in terms of health check, to make sure that Kibana is up and running, we're just going to ping it on port 5601 to make sure everything is fine. And that will determine whether this Kibana container is healthy or not. So just like that, we should be able to restart Docker and actually log in to our Kibana and Elasticsearch instance. So let's try this out. All right, and then let's just do docker compose up. So this might take a little bit longer because sometimes Kibana just takes a little bit more time to start up. So I'll pause until it's actually up. Okay, I think things are finally up. It actually took a little bit longer when I did a Docker logs on this container. So what I mean to say is that even though this said started or healthy, when I did a Docker logs on this container, it showed that there were still logs indicating that it was still trying to load up. But now that it's up and running, I'm actually able to go to the IP address of my Red Hat Linux machine, and now I can see this that SSL is being used. And because it's it's a self-signed certificate and we're using our own certificate authority, we're going to see this screen, which is a good sign. It means that no one else is aware of this certificate authority, right? So it's in some ways more secure than using a publicly signed certificate. So I'll accept the risk and continue. And now we should be able to log in. And the password is change me, okay? So the Elastic is just a super user account that comes with every installation of Elastic. All right, looks like we're able to log in. So just like that, we've got our Elasticsearch container up and running, Kibana up and running, and at this point, we can install any one of these containers. So I'm just going to take a quick break, and then I'll be back. All right, so I'm back now. So let's go ahead and set up the rest of these containers. I think we'll just start from Metricbeat and just go from left to right. Let's go back to our terminal window over here and open up our Docker compose file, go to the end, and let's add in our next container. Let's go over here and scroll down. So here's the Metricbeat container. So we'll copy this. And I'll paste it in here. All right, so let's see what this does. This container depends on a healthy instance of Elasticsearch and Kibana. And once those are healthy, then this container will try to download the Docker image for Metricbeat from the Elasticsearch repository. And we're going to run it as root user, and we're going to need a few volumes. So the first one is Metricbeat needs to connect to both Kibana and Elastic, so that it will need the certificate authorities that we created in the setup container. So we're going to volume mount this certs directory to our local machine's certs volume. We're also going to need to create a new volume call for Metricbeat data, because if Metricbeat needs to store any kind of information that we want to persist for each new run of Docker, then we're going to need to have a place to permanently store that data. So let's set up this container or let's set up this volume over here. Oops. Paste. Okay, there we go. And that's going to be driver local. Oops. There we go. All right, and that's also specified here at the top. Okay. So coming back down here, so we've got that volume mounted. We're going to need a Metricbeat YAML file. So every single beat, whether it's Metricbeat, Filebeat, or if we installed AuditBeat, PacketBeat, or Heartbeat, or any of them, just like Kibana and Elasticsearch, we can use a YAML file to configure how that particular instance or how that particular service should run. So we're going to need a metricbeat.yaml. It's going to be read-only. So in the container, it's under this path, but we're going to bind mount it to our machine. So bind mount, because then we can choose exactly where on our host machine it should be. So let's create this file, and we're just going to grab it from this project over here. That's this one. So I'll just copy all this and paste it in here. There we go. So I have a video that I've done earlier on how to install and run Metricbeat. So I won't go into all the configuration options that are available in this file. You can just watch my earlier video on that. I'll leave a link in the description of this video to that other video. But I'll quickly mention a few things. One is that we're going to look in the containers modules.d directory for any YAML file that have been enabled. So this window here is a completely different server that actually has Metricbeat installed on it. And inside this modules.d directory, we actually see a bunch of YAML files, in this case, that have been disabled. But if you enable any of these, then Metricbeat will monitor that that particular service. And that's what this line here is trying to do. Okay. And then you can see that we're going to monitor health, just some health about the Elasticsearch container, health about the Logstash container, which we don't have yet, but we will eventually have it. And when it's actually enabled, when the Logstash container is running, Metricbeat will be able to automatically pick that up. We do have a Kibana container, so we're going to monitor some of those services. Oh, and by the way, I forgot to mention that each of these modules can be represented by a YAML file in this directory over here. So you could choose to enable it through this by removing the .disabled suffix to these file names, or you can explicitly mention it inside as a property of this metricbeat.modules section. All right, so hopefully that's clear. Okay, so coming back here, we're going to monitor some things about the Kibana container, and we're going to get some information about our overall Docker service, and that's pretty much it. And connect to Elasticsearch. So again, if you want more details on how this YAML file actually works, just watch my earlier video. Okay, so coming back to here, so we've got a read-only on the metricbeat.yaml. Now, in order for Metricbeat to read information about our Docker service, to read information about our actual host machines or the health of some of our containers, we actually need to bind mount to the sysfsc group, the process directory, and the root directory here as well. And then these environment variables are actually going to be passed over to our metricbeat.yaml file to do whatever it needs to do to be able to connect to Elasticsearch and Kibana. So that's pretty much it for the Metricbeat container. So let's try to start things up. Remove orphans, and actually let's just docker compose up, build. So let's just restart everything just like that. So this actually might take a while, so I'll pause until everything is up and running. All right, looks like things might be up and running. Let me just go back to my tab here. I'm gonna hit refresh just to see if it's actually running. Okay, good. Sometimes you might see things are still waiting or it's not available yet. And if that were the case, I would just go docker logs Kibana and just see if there's any unusual issues in here. Oh, okay, I wouldn't worry about these yet. It's just saying that the APM server and Fleet server is not set up yet. Well, that's because we never got around to that yet. I could have just removed the relevant lines from our Docker compose file for something like this, or our Kibana.yaml file. We could have removed lines pertaining to APM, and these error messages wouldn't show up. But the good thing is at least Kibana is up and running. And if I go to observability, let's say over here, I can see that, yeah, we're getting some Metricbeat data for this host machine. And let's see which one that is. That would be this one, this Metricbeat container, one ending in 84. All right, so we're able to grab information on the health of that particular container. All right, so we got Metricbeat up and running. Let's see what we want to do next. Let's get Filebeat running. All right, so to get Filebeat running, we'll go back and go to here, doc compose YAML file, and let's just grab the next container, which is Filebeat, this one over here. Copy, and let's go to our docker compose file, go to the end, paste it down here, and let's go through this line by line again. To get Filebeat to work, we're going to need the Elasticsearch instance to be healthy. Once it's healthy, we're going to download the Filebeat image from the Elasticsearch repository. We're going to run things as the root user. And again, we're going to need to use the certificate authority from the certs directory to be able to connect to Elasticsearch. Filebeat will need to store some configuration or just running instance data to our host machine. So we're going to need to create a volume for that to work. So I'm just going to copy this. Go up here. Let's make a new volume. Whoops, too much. Paste. There we go. And it's going to be, again, a volume mounting to our local drive, which is the Red Hat machine. And let's go back down here. All right, so we've got that set up. For Filebeat, we're going to ingest our own custom logs. So inside the container, we will read it from this directory here, ingest data. But that's going to bind mount to our local machine, our Red Hat machine, in this directory here. So we're going to need to make this directory on our computer. So let's do this. Okay, great. We've got a directory there. And let's actually just put in some data. No, wait, before we do that, let's just move on to these next few lines first. I'll put data into this directory in a moment because I need to know what type of data it's going to consume. And that will be explained in this YAML file. So the container is going to read this YAML file, which is used for configuring Filebeat. And I'm going to grab it here. This one over here. Let's copy this. Okay, so this will tell us what type of data we're ingesting. Up here, we're going to ingest anything that ends with a .log file. Okay, so let me just... Right. Okay. So this ingest directory is going to be is referencing this one. Great. So this means this, and this means this, which means we can start putting any .log file into this directory. So I'm just going to copy just any random logs I have. What do I have? This cron file? Sure. I'll put it into this Filebeat ingest data directory as cron.log, because anything that ends with the extension .log will be picked up by Filebeat. And I will make an edit so that things will be easy to find. I'm just going to update the message here. And maybe I'll type in something like a keyword, bicycle. Yeah, I'll just type bicycle, and we'll search for that this particular word in Kibana afterwards. Okay, so we should be set up from that front. Let me see if there's anything else in this file I should explain. So I have a video on Filebeat where I explain most of these options on how to modify this Filebeat.yaml file. So I'll link to that video in the description of this video. But for now, I don't think there's anything too interesting, just that we're going to read from .log files. We're going to connect to Kibana with these environment variables and connect to Elasticsearch with these environment variables. Okay. And anything else? All right, so Filebeat wants to know some information about our Docker containers and our running information about Docker. So that's what these two lines are for. These are the environment variables that we're going to pass over to our Filebeat to the initialization of Filebeat. And you can actually see them used in our Filebeat.yaml file. All right, so these variables came from over here. And that's pretty much it. Let's go ahead and start things up. So we just run the same doc compose down and doc compose up. So I'll pause until this is all up and running. All right, looks like things should be up and running. I'm going to come back here and I'm just going to hit refresh to see if this module gets updated. Okay, so this looks kind of good. There we go. We have a logs module here. So that indicates that Filebeat is up and running. And if you recall, I wrote the word bicycle in this file down here. So let's try to search for that. Now, to be able to search for information through the discover option here, oh, actually, it looks like, oh, that's pretty neat. I think we might be able to, actually, I was expecting, what do you call it? Filebeat to appear here. Right, it looks like we actually have to create a Kibana data view first. So I'm gonna go down to, I believe, dev tools. Oh, not dev tools, stack management. And we're gonna create a new data view. Create data view, and that's gonna map to Filebeat. There, this one, Filebeat, just anything that starts with Filebeat. I'll call this Filebeat as well. And this will allow Discover, allow us to use the Discover tab to query data in the Filebeat index. That way we can create our own widgets and dashboards afterwards. All right, so this should be good. Let's go to Discover. We should have Filebeat now. And if I look for the word bicycle, hopefully it does show up. Here we go, bicycle. All right. So now we know that we're properly ingesting files out of the, we're ingesting this file, and we're basically taking any files inside this Filebeat ingest data. All right, so we've set up Filebeat, and now I think we can move on to Logstash. So let's do that next. I'm going to come back over here, and let's go to our doc compose file. Let's grab the next container. That would be this one over here. copy. And I'm going to open up the Docker Compose file here. Go to the bottom, and let's just add this container. All right, so for this Logstash container, again, it depends on the healthy status of Elasticsearch, a healthy status of Kibana. Once that happens, we'll download the Logstash Docker image from the Elasticsearch repository. And again, just some labels to help with logging with Elasticsearch, or logging within Docker containers and auto discovery and such. We're going to run this container as the root user. We're going to need the certificates to connect, the certificate authorities to connect to Elasticsearch and Kibana. And again, we're going to need a volume to mount some some system information about Logstash so that we can preserve some settings. So let's, let me just paste. Oh, I may have lost it from memory. Let's just do this again. Paste in here. All right, so we've got that. Now we're gonna consume data out of our Logstash ingest data directory. Inside the container, it'll be referenced with this directory. So let's make this empty directory. Oops. There we go. We've got the directory. All right, and we're going to need a Logstash configuration pipeline, which the container will reference as this. So let's grab that configuration pipeline from over here. All right, so I'm going to grab this, copy, and logstash.conf. All right, so this is a pretty straightforward, nothing particularly special. Just read all the files that come out of this ingest data directory. This ingest data directory maps to this directory, and this directory maps to this bind mounted volume over here. All right, so that's the Logstash configuration file. Once we've got any information, we will just throw it to our Elasticsearch based on these connection details. And we do have access to the certificate authority because of this volume mount over here. And in terms of the Elasticsearch connection details from here, that's basically these environment variables that we pass along to it. So let's throw another file into, actually, I'm going to do cp filebeat ingest data, and let's copy this over to our Logstash ingest data. And I'm going to simplify things a bit. And let's just delete everything except for that bicycle record. Or maybe I'll leave one more record. I'll just leave these two records here, like that. That way, when we search the index, it'll just be easy for us to notice right away that these two records made it into our index. All right, so I think that's all we needed to do. Let me just double check. Yeah, that's pretty much it. I'm going to restart everything. And it might take a moment, so I will pause until this thing is up and running. All right, looks like things should be up now. Now let's go to our stack management. Take a look at the indices. Okay, looks like nothing made it in here. Let's just make sure our Logstash container is running fine. I'm gonna use the Docker ps command, but a formatted version so we can see everything. All right, so Logstash is up and running according to this. Let's do a Docker logs here. It seems that things have been initialized. Okay, let's reload here. Okay, let me just see what the container, the index name was supposed to be. We're expecting a index name Logstash and then hyphen and a timestamp. All right, I paused for a moment to investigate why things didn't show up, but now suddenly things did. Suddenly the index for Logstash did show up. The only thing I did differently was I actually logged in, or I actually opened up my. Oh, hold on, my keyboard's frozen. Oh, there we go. I just opened up my cron.log file. I added one more line down here with the word mountain in it. Either maybe the fact that I updated this file is what triggered the Logstash to ingest the file again and create this index. Maybe that was it, or maybe I just had to wait a little bit longer. I know that sometimes if a log file is a little bit too old, there's a setting somewhere that you can change on how recent of a log you want to pick up. Maybe if that timestamp, or maybe if this log is too old, initially Logstash may not have picked it up. In any case, this latest row, by adding this latest row or by waiting a little bit longer, I finally have a new Logstash index here. And if I go to DevTools, I should be able to search it. Get Logstash, and let's do a search. And let's see what shows up. All right, we got 3 records. We see the first one that came in. Yep, so I see mountain here. And I see bicycle here. And I see that startup up here. So that would be, that would reflect each of these records here. All right, so just like that, we've got Logstash up and running for this container over here. All right, so next, let's actually set up the container for our Elastic Agent, Fleet Server, and APM. Now, this is a pretty complex topic because I've actually created a whole playlist on each one of these items. Something to talk about Elastic Agent, something to talk about the Elastic Agent policy, then to talk about the Fleet Server, and then to talk about APM. So I'll link to all those videos in the description of this video. If I were to just shorten the explanation of everything, I would say that the Elastic Agent is basically a tool or a service that you run that controls all the different integrations that you can have with Elasticsearch. In this particular instance, we're going to create an Elastic Agent that creates 2 different integrations. One integration called the Fleet Server and another integration for APM. Now, the Fleet Server is really good at managing many different Elastic agents, but it's pretty much the standard way that Elasticsearch wants you to use for setting up Elastic agents or managing them. Okay, so these 2, Elastic Agent and Fleet Server, often go hand in hand. And the APM is just a separate integration that we plan to use with our Fleet Server and Elastic Agent. And this APM will then be used to track the performance of a Python web app that we'll set up last. But let's go ahead and set up this container first, the Elastic Agent, Fleet Server, and APM. We're going to come back here and go to the Docker Compose YAML file, and let's get the Fleet Server Elastic Agent container, which would be this one. Right? It's really just one container that does all 3 things. So there's going to be a lot to unpack here, but let me just paste it in here for a moment. And I'm going to paste it in here. All right. All right, so let's explain this stuff line by line. Now this one container does all 3 of these things. So it's a little bit deceptive on how something simple like this can cover 4 or 5 videos that I've created in the past. All right, so let's go through this. Now to set up this Fleet Server container, it's going to depend on the healthy status of Kibana server or the Kibana container and the Elasticsearch container. Once that's done, we're going to download the Docker image for the Elastic Agent. Okay, and this Elastic Agent is the tool that we're going to use to spin up the Fleet server and create the integration with APM. So I'm just going to show you this command over here. If you recall from our earlier videos with Elastic Agents and Fleet server, you'll notice that on our actual Linux machines, when we've downloaded the Elastic Agent, we can run this binary or this command .elasticagent install, and then we have to give it a whole bunch of options to be able to enable the Fleet server, APM, and other things and other integrations. This Docker image here is essentially this command that we will be needing to run. Okay, so that's what this one line, or that's what comes bundled with this image. All right, so we're going to need the certificates again, so we're going to volume mount it. The Fleet server does have some data it needs to store on our host machine. So I am going to create a volume for this. Okay, and let's come back down here. All right, so we've created the volume. And just to make sure everything runs properly, we're going to do a read-only. We're going to give the container read-only access to information about Docker containers, the Docker socket, some system processes as well. The Fleet server internally inside a container is going to run on port 8200 or 8220. But we're going to map it publicly to, or externally to, let's see what it is. We're going to also use 8220 here. Right? And for APM, for our Python web app, it's going to talk to this port here. Okay, so also 8200. So we're just going 8200 to 8200 within the container. All right, so then we're going to run this container as the root user. And for all these environment variables and files, this is part of what this will do is it sets some of these properties that I've discussed in my previous videos on Elastic Agents and Fleet servers. So some of these will come to here. Others, some of these other flags will actually just do some, if you recall from our APM integrations tutorial, there were still a few point and click things that we need to do to get some integrations up and running. Some of these flags here will help us with that. Oh, something. I don't think we actually need I think we can actually remove this line. In fact, I'm just going to delete it. These are saying that the connections will be insecure, but because we're actually using self-signed certificates, I think things should be secure. So we're going to force the SSLs to be used. So I'm going to delete those 3 lines, and I think things should still work. All right, so let's just try getting this up and running. Okay, so I'm just going to pause until this is up and running. All right, I think things should be up and running now. Our Fleet server is showing that it's healthy. So I think I should be able to go to Kibana and take a look around. Let's go over here. Let's go to Fleet. All right, so I think we're going to need to configure a few more things here, because what we want to see is that we want to see if the Fleet server or the Elastic Agent is able to pick up the CPU and memory usage, but it isn't able to right now because there's still a few more things we need to do in the settings here. So I'm going to go to output, and we're going to need to update some of this information. Our Elasticsearch is actually the container name that we specified in our Docker compose file. It's going to connect on SSL. We're going to need the CA trusted fingerprint. So for that, I'm actually going to need to copy the certificate authority file. Actually, do I have it here? I forgot if I... okay, so we're going to copy it from our Elasticsearch container. So I'm going to go docker cp es cluster, this one, es tab. Okay, there we go. And I believe the certificate should be found in this file. I have it here. I have it on another screen. I'm just going to copy and paste it. So inside the Elasticsearch container, our certificate authority is found here. And we're going to copy it just, let's say, right over here. All right, so we have our ca.cert file now. Now we're going to need to get the fingerprint for it. So I'm just going to copy a command that I have. Let's copy and, oh, let me just, all right. So using the OpenSSL command, which comes with most installation of Linux, I'm going to read my .ca cert file and just output the fingerprint. So we're going to need this and paste it into here. All right, and next we're going to actually need the contents of our CA file. So I am going to just do .ca cert. We're going to need this, and we're going to need to format it in a certain way. So let me just open up another text window. All right, so I'm going to paste it in here, and it has to be in the YAML notation. So I'm going to do this, certificate authorities hyphen, and make sure these are spaces and not tabs. 1, 2, 1, 2. Okay, that's good. And then 1, 2, 3, 4 spaces. And I'm going to need to do that for every single line. And these spaces do matter. It can't be tabs. It's got to be these spaces, or else we're going to get some errors. And in one of my earlier videos, I also talked about fixing a certificate authority issue, and we fixed it by pasting in the CA just like this into this advanced YAML configuration area here. All right, so that should be good. Let's just press submit, save and deploy. And I'm going to click back to agents. And we'll know things are working once I start seeing CPU and memory usage in here. So I'm going to pause until that happens. All right, this is looking good. Our Fleet server is up and running. I see my CPU and memory there. I'm just going to hit refresh to make sure this doesn't go to unhealthy. Yeah, it's been up for a minute or so and it still remains healthy. So that's a good thing. If it goes unhealthy, you might need to troubleshoot things a bit. If you look at some of my earlier videos on how to do that, it'll explain where you can find logs for the Elastic Agent. Now, because they're in a Docker container, you might need to go into the container to look for those logs. All right, so we've got the Fleet server with APM up and running. In fact, let's double check over here. Yeah, we've got the Elastic Agent. We've got the application performance monitoring integration also as part of this policy. So we can actually start instrumenting some kind of software app and stream metrics to APM. And that would mean let's set up some kind of web app here. And the Elastic team here has already given us a Python app. So let's actually just download this file. I'm just going to open this up, Python. Let's copy this, make the directory called app, main.py. I'll paste it in here. So I'll explain what this Python code does in a moment. But before we do that, we also need a Docker file. And what this Docker file will do is it's going to give some extra information to Docker Compose on how to build this Python application. So I'm going to click back and just take this Docker file, copy, and I'll paste it in here. All right. So in terms of how we're going to build this container, it's going to use Python 3.9. We're going to load the information or all this Python code out of a directory called app. That directory is actually inside the container. It's not on our host machine. we need the requirements.txt because we're going to do a pip install to download all the necessary packages. All right, so let's actually make sure we have this file as well. Copy. I'm just going to exit out of here. Requirements.txt. And let's go back here. All right, so do a pip install to download all the Python packages and modules, which main.py will use. And when we actually start up the Python container, we're basically loading up a website on the localhost on port 8000. All right, so that's what our app is going to be. And in terms of how this Python code works, now I'm not really a strong Python developer, but so from what I can tell here, it's really just setting up a typical website with a few routes where you might be able to ping an endpoint for custom message. This is the home directory and a few other directories. I think the most important thing that you want to note is that in here, when we set up the website, there's going to be some buttons. And one of the buttons will cause a Python error, which calls this function, or it can cause a JavaScript error, or it can cause another, custom message. And in those functions, so you can see this function Python error, this JS error, which we referenced above here. All right, so these are the event handlers. Within these functions, you can see that there is a call to the APM server, apm.capture exception. And these will transmit data to APM, and that will verify whether APM is running correctly or not. Now, in my earlier videos on APM, I've shown how to do similar things with Node.js and also another example with Golang. So if now between these three examples, you should know how to do APM with Python, JavaScript, and Golang. In the future, I'll do APM for a few other technologies as well. Okay. All right, so we've got our Python app in here. We're ready to configure the container from the Docker Compose level. So I'm going to click back, and come over here, and let's grab the last container, which is this one. And let's add it in here. Oh, let me just make sure I'm at the bottom of my file. Yes, I am. And this will be our Python web app. And we're just going to read some information from our local machine and then run this website on port 8000. So let's restart. Okay, so I'll give it a moment until everything is done. All right, took a couple of minutes. Hopefully everything is running fine. Okay, everything is still up and running for the last 2 minutes. So I think we should be able to go to Kibana now and click over to APM, and let's see what we see. Observability, here it is, APM. All right, so APM recognizes that there will be a Python web app, but it doesn't have any data yet because we haven't opened up the website. So let's open up the website. All right, so I'm on this website. This is the Python web app. Let's click a few buttons. And let's go back here, hit refresh. Okay, so we're already seeing some metrics in here. In a moment, we might see even more data in here. Let me just hit refresh a few more times. And we'll see what comes in. There we go. So now you see that we've got APM working as well. So I think at this point we've covered every single container here. Hopefully I didn't miss anything. If I did, I will try to create a follow-up video to answer, to fill in any gaps or answer any questions people may have had. Oh, and there's one more thing. If I get a chance, I want to make another follow-up video related to Elasticsearch security, because we didn't talk about security for anything in this video. So hopefully I can follow up with that in a future video.